Okay, this video is about drawing angles in standard position. This is a revisit of learning targets 1, 1A, and B, which we've previously done in degrees. We're now going to come back and revisit them in radians. The first and most important thing that we need to do when we talk about drawing angles in standard position in radians is to think about how our axes have now changed. So previously we said that we would always start the positive x-axis as our 0, positive rotation going this direction. That would bring me 90 here, 180 here, 270 here, and 360 here. Now we're going to be in radians. So we've talked in class about how in radians this position is still 0 radians, but now if I go all the way around instead of 360 degrees, it's 2 pi radians. Halfway around the circle would be 1 pi radian. Half of that would be up top as half of pi, which we also could write as pi over 2. I just want to shorten this here so I can get that in there nice. And then halfway between 1 pi and 2 pi is 1½ pi, which we'll write as 3 pi over 2. So if someone asks us to draw an angle in standard position, we still need to do the same 4 things that we did before. The 4 things that we need to do is we need to draw and label a terminal side. That's our side that rotates. An initial side. We need a rotation spinner. It's not a technical term, but it's the best thing I can think of to call it so you know what I'm talking about. And the last thing that we need is a labeled reference angle. Again, remember that the reference angle goes to the closest x-axis, is acute, and is positive. So now, because radians have fractions, they're inherently more difficult to draw. So for instance, let's say, let me start real basic here. For example, I want you to draw an angle that measures, let's say 2 pi over 3 radians. So if I want to do that, the first thing I want to do is I want to think, where does 2/3 of pi fall as I go around my rotations? So this is what I mean. Is 2/3, is it between 0 and 1/2? That would be quadrant 1. Is it quadrant 2, which is from 1/2 pi to 1 pi? Is it 3? So does that value fall between 1 pi and 1½ pi? Or is it going to be in quadrant 4, which will put me from 1½ pi to 2 pi? So in order to answer that question, all we need to do is we need to look at the fraction in our question. So 2/3 is clearly more than 1/2 and less than 1. So this guy right here is going to fall in quadrant 2. So my terminal side goes somewhere over here. Exactly where, I don't know, but this is good enough. Our initial side goes there. This is a positive angle. It's rotating around less than 1, so I'm going to start at 0. Start at 0, and I'm going to give my positive rotation with my arrow. The last thing we have to do is label our reference angle. And our reference angle in this picture is right here. So I know that this is 2/3 of pi, and the reference angle needs to take me to 1 pi. So in order for me to figure out its value, just figure out the difference between those two numbers, 1 and 2/3. So this reference angle right here would be 1/3 pi, more commonly written as pi over 3. So we'll see if that makes sense. So let's try another one. So let's say that now I want you to draw an angle that measures, I don't know, let's go with 7 pi over 5. And I know it's in radians because there's that pi in there that guarantees it for me. So I'm thinking, again on my axes, between 0 and 1/2 pi, 1/2 and 1 pi, 1 and 1.5 pi, 1.5 pi, and 2 pi. So the value that I'm thinking of, this is 1, well, this is 7/5 of pi, so times pi. And if I take 7/5, I can write it as a mixed number, pardon me. So that's 1 and 2/5 pi. That helps me to know that it's more than 1, so it's not in quadrants 1 or 2. In fact, I know that it has to be in the bottom half, in the negative y area of my coordinate axes, because it's more than 1 and it's less than 2. The question is 2/5 more or less than 1/2? 1/2 of 5 would be 2.5, so this would be 2.5 fifths. So I know that it's less than. So as a result, I know that my terminal side in this example falls somewhere in quadrant 3. Initial side's where it always is. This is a positive angle, so I'm rotating in this direction. Last thing I need to do is label my reference angle. So again, we know that this here is 1 and 2/5 pi, pardon me. 1 and 2/5 pi. And I want to go back to 1 pi. Reference angle is always the closest x. So this guy right here is 2 pi over 5 radians, and that's my reference, and we're all set. So I think it becomes pretty clear as we're working on this that we need to figure out how do we know what our reference angle is based on our quadrant. So we're going to summarize those rules for the reference angles in radians. So if I'm in quadrant 1, so if I'm over here, in these cases my reference angle is always going to be here. So it's going to be the angle in quadrant 1. So for example, if I asked you to graph, I don't know, pi over 4, it goes here. And the reference angle is just from 0 to pi over 4, so I would label the pi over 4. The other way I can see that is if I go more than one rotation. Let me do something like, oh, I don't know, 7 pi over 3. And 7 pi over 3, I know that this is the same thing as 2 and 1/3 pi. That's how I think of it. So I know the 2 brings me around 1 full rotation. There's my spinner. And then I'm going 1/3 of the way to pi more. So I'll be around here. So I know that this is coterminal with 1/3 pi. So this drawing is the same drawing as 1/3 pi with the extra rotation. I'll represent it right there. So this angle in quadrant 1, the reference, is just how much more than that 2 pi it is. So in this case, 1/3 pi or pi over 3. If I'm in quadrant 2, my picture maybe looks something like this. I'm rotating in this direction. So now my reference angle is here to the closest x. So that closest x will take me to a location of 1 pi. So for example, if I gave you an angle of, I don't know, 4 pi over 5, I know that that picture is more than 1/2 pi, so it's putting me somewhere around here. Nope. Somewhere around here. And then if this is 1 pi, and that's 4 pi over 5, the difference between 4/5 and 1 is 1/5 pi, so this would be pi over 5. Again, I can do it in the other or with more than one rotation, or I could give you a negative angle. Let's say it's negative 11 pi over 10. That's the same thing as negative 1 and 1/10 pi. So when I graph it, it's helpful to think of it in that way, because here is negative 1 pi, and then it's going 1/10 pi more. So if this is negative 1 and 1/10, to here was the 1 pi, and this would be the 1/10 pi. So my reference angle here would be positive pi over 10. That's quadrants 1 and 2. Quadrant 3 continues something similar. So in quadrant 3, I'm down here. This is my reference. So it's a difference between 1 pi and whatever this theta is, or whatever the angle of rotation is. So quick example, I'm just going to do one. I'm going to say that this is 7 pi over 6. That's 1 and 1/6 pi as a mixed number. So I know that it's over here someplace. It's a little bit more than 1 pi. That brings me to here. How much more than 1 pi? That's the 1/6 pi. So pi over 6 is my reference there. And last is if I'm in quadrant 4. If I'm in quadrant 4, my reference is here to the closest x. So that's going to bring me up to 2 pi. So for example, I don't know, let's say that it is 11 pi over 6. So that is 1 and 5/6 pi. 5/6 is more than a half, so this is more than 1 1/2, so I know that I'm down here someplace. And I want to get up to 2 pi. The difference between 1 and 5/6 and 2 is 1/6, so this would be a pi over 6 reference. So that would be how we find our reference angle in each of the quadrants. And that's that. So we've talked about graphing in standard position. Still have the same draw, terminal side, initial side, rotation, spinner, and reference, but now we need to go ahead and we need to keep track of our angles, reference angles in terms of radians, and we just did a quick review on that. I understand the fraction work can be a little bit annoying. The only way that I can kind of trick you on this is if I were to talk about, I don't know, if I asked you to draw something like 2 pi, or sorry, not 2 pi, if I asked you to draw something like just 2 radians. Now that's a little bit harder because there's no pi. So we get in the habit of thinking that pi just is like a unit, but it's not. It means 3.14. So really, when I'm doing this, this is 0 or 6.28 roughly. This is pi, which is about 3.14. This is halfway between 0 and 3.14, so it's 1.57. And this is about halfway between 3.14 and 6.28, which is the one I always have the hardest time doing off the top of my head, about 4.71, right? This is 2 pi, this is pi. I'm just writing the decimal equivalents of these things. So now if I want to graph a whole number or a decimal quantity of radians, I can compare them to these labels versus the labels in terms of pi. So I can see that 2 is more than 1.7 and less than 3.4. So I'm going to put it over here someplace. Here's my rotation. The question is now, what is my theta? What is my reference angle? So that reference angle is the difference between 2, which is up here, and exactly pi. I don't want to use the 3.14 because that's not exact. So I'm going to say that my reference angle here is pi minus 2 radians. That would be the exact. That's the trickiest that I can make it. I will not start off there, but we eventually will see some questions that look like that. Last concept that we need to mirror into radians is the concept of coterminal angles in radians. Now we say that coterminal angles have the same terminal side location, the same quadrant, same reference angle. However, they vary by a number of rotations. So if we remember in radians that one rotation equals 2 pi radians, and we know it equals 360 degrees. So we're in degrees. Coterminal with 10 degrees would be 10 plus the rotation of 360, or 370 degrees, or 10 minus 360, which is negative 350 degrees. Those are great. But now, if I give it to you in radians, you need to keep it in radians. And again, here's where the fraction bit comes in. If I start with something basic, like coterminal with 1 pi, that's easy to do. I can do 1 pi plus a rotation, which is 2 pi. So I could see that 3 pi is coterminal with 1 pi, or take 1 pi and subtract the rotation. So I can get that negative 1 pi is coterminal with 1 pi. Where it gets tricky is when I start to think about fractions of pi. So if I have, let's say, 3 pi over 4, and I want to find an angle coterminal with it, I want to say that's 3 pi over 4 plus a rotation, which is 2 pi. Now I need to remember to add fractions, I need a common denominator. So if I wanted to add 3/4 and 2, I would need to rewrite 2 with a denominator of 4 first. Then we keep the denominator and add the numerator. Same idea here. I want to say that this is 3 pi over 4 plus 8 pi over 4, which gets me to 11 pi over 4 being coterminal. Same if I subtract 3 pi over 4 minus 2 pi. I want to rewrite that as 3 pi over 4 minus 8 pi over 4. Now remember, keep the denominator. My larger quantity is negative, so this is going to be a negative answer. 3 minus 8 is negative 5. So this is negative 5 pi over 4, also coterminal. So additional trickiness just coming from the fractions, not from a change in the concept of what coterminal angles mean. I think that should just about wrap it up for switching all of our concepts over into radians. Now I'd like you to work on practicing some of those concepts on the worksheets that you have received in class. Thank you.